can you read out your homework for us, please?
Vehicles such as cars, motorbikes, bus, trains are running by petrol. Petrol is a type of non-renewable resource that is a fossil fuel. Petrol is made by crude oil and coal. When the vehicles run, they burn the petrol and make it turn into gas and flues out of a special pipe in the bottom of the vehicles.
Okay. And Bill, what about this question? What about technologies that engineers build to replace fossil fuels? Can you give me one technology that engineers build to replace fossil?
They will use other type of energy.
Yeah, give me an example. Give me one.
Wind,
Okay.
sun.
Cool. Thank you, Bill. Thanks very much. James, your homework, please.
Yes.
Can you read out your homework for us, please?
Okay.
Hello.
Here, the cars use gas and oil, but electric cars can use electric to move. Oil and gas are non-renewable because it cannot replenish fast. They need thousands of years to form. Electricity are renewable because it can form by turbofan spinning by wind. Oil can be used out, but not quickly. Electricity can be charged and safe for the environment.
Yeah, okay, good stuff. James, be careful there though. Not thousands of years, millions of years, okay? Millions of years. Millions of years. We'll do two more. Let's go. Read out your homework, please.
Now people have two types of cars. One car is using crude oil to run on. Crude oils are non-renewable resources. They are fossil fuels and they need thousands of millions of years to form or made up. Crude oil can be used up and then there will be no more, so we cannot run the vehicles. The second type of car is alternative car. They are run by electricity. They use wind or water energy, so they are renewable resources. They can never be used up, so we can save the environment and run the vehicles.
Some old cars use crude oil, but new cars can use renewable fuel that can easily be produced by water or wind. Crude oil is a non-renewable resource. If we use too much crude oil, there will be no more crude oil. Engineer now build an electrical car and it don't use fossil fuel. The drawback of electrical car is that it can be high cost, but it don't use fossil fuel. The drawback of coal is the drawback of natural gas is natural gas must be handled carefully because it is a combustible material. Natural gas is environmental friendly because it burns cleaner than other fossil fuel.
Okay. Cool. Yeah, good job. Well done. Right. A lot of you gave really good answers there. Identify types of fuel source. It can be petrol, it can be electricity. Sources are renewable, non-renewable. You all answered that very well. Technologies: wind power, solar power, geothermal, and a lot of you spoke about the drawbacks and benefits there. Really good job. Well done. Okay, so what we're going to do today is we're going to spend some time talking about renewable forms of energy and just renewable forms of energy. Okay, we spent a lot of time talking about coal and oil and natural gas and nuclear power and what it takes to take them out of the earth and the drawbacks and the negative effects of it. But this time we're going to spend more time talking about renewable forms of energy. In particular, we're going to talk about 5 or 6. So, Laura, tell me one renewable form of
Water.
water. What's the name we give the renewable form of energy we get from water?
Hydroelectric energy.
Hydroelectric energy. Good job. Well done. Kent, tell me another form of renewable energy. Another form of renewable energy.
Sunlight.
Sunlight, right? What's the name we give the type of energy we get from sunlight?
Nuclear energy.
No, not nuclear. Begins with S.
S.
Yeah. Rhymes with polar.
Solar panel.
Solar, yeah, solar energy. Good job. Well done. Guy, can you tell me another one?
Hydroelectric.
Hydroelectric, yeah, so you got water. Emily, another one?
Wind.
Wind
Energy.
power. Wind power. Okay, there's a couple other ones that we spoke about a little bit, but we haven't gone into too much detail. Again, please, cameras on, okay? So, renewable energy, we explained this before. It's energy that comes from natural resources, energy that we're not taking out of the earth, right? It's available to us. We're using the natural power that the earth provides us, either by the sun, or wind, or water. And what we're doing is we're using that to create energy. We're using that to make energy. The difference between non-renewable and renewable is we can keep using it. It's going to keep coming back. It's going to keep replenishing, right? The sun is always there. Wind comes from the sun. If we have sun, then we're going to get wind. We have waves. What makes waves? What causes waves? You can tell me the answer. Big giant thing in the sky. You really see it at nighttime.
Wind.
No, wind helps. Yeah, wind helps. But there's another one.
And movement.
No.
Current.
Minerva.
The moon.
Moon. Yeah. Oh, that's interesting. I'm pretty sure Minerva was the goddess. No, sorry, Minerva wasn't the goddess of the moon. I get confused. But yes, the moon, right? Moon's gravity and the moon's gravity causes waves, and we use this to create energy. So we looked at this in lots of detail. We use energy for gas to heat our homes. We need energy to power our cars, diesel, oil, made from crude oil. We use it for fuel. Then we use electricity to power lights, televisions, computers. So we use energy for lots and lots and lots of things, right? And we've looked at the idea of non-renewable resources. We rely on energy. We rely on power. Without power, without electricity, we will not be able to do all these things. We need to find new ways to do it, because non-renewable means it's going to disappear at some point. When it's all gone, it's gone, and we can't use these things. So there's lots and lots of renewable types of energy. So solar energy, this comes from the sun. It can be used to give us heat. Solar panels are used to convert sunlight into electricity. Also called photovoltaic cells, okay? Normal battery you would put in your toy car is called a voltaic cell. A photovoltaic cell refers to batteries powered by the sun. Photo is in referral to the sun, right? What happens is the sunlight hits the solar panel and it absorbs photons. Remember, we learned about this in light energy, a photon. A photon is then used to create electricity. So it starts to store all of the photons from the sun, and from that it creates electricity, which we can then use. Who has ever seen solar panels before? Again, you don't see it so much here in Hanoi, but back at home where I'm from, a lot of houses would have solar panels on their roofs. Just to do something small, like heat the water in the house or to keep the house warm. It wouldn't be to power the whole house, but it would be to power a small part. What do you think a drawback of solar energy is? What do you think? What's a con or a drawback of solar energy?
It can be too hot.
Be too hot? You definitely don't want to touch a solar panel. That's definitely true. Okay, what do you think a drawback of a solar panel is?
It's expensive.
Expensive, right? They're not cheap. They're not cheap at all. They are expensive. What else? Minerva.
When there's no sun, the solar panel won't work.
Exactly, right? It depends on there being sun. If it's too cloudy like it is today, we're not going to be able to get much power from it. Exactly, right? So there are limitations to it, which is unfortunate because it's a really good source of energy, but there are limitations. Also got wind energy. So here you have a wind turbine. What happens is the wind spins these turbines, spins these blades. What they do is they spin another turbine down here. It's got a really big magnet inside, right? Inside, when the magnet is spinning, that's creating electricity. They then take the electricity that's coming from the magnet and they store it. They can use it to power anything really. Like it's a really good source of energy. Eva, have you ever seen wind turbines like this?
Yes, on photo.
In photos. Oh, okay, in photos. What you don't see is that these are huge. Again, really close to my house, out to sea. Put the wind turbines out to sea. These blades here are about the length of a football pitch. They're about 100 meters long. They are very, very big, and they're so noisy. Make so much noise. You can hear them out to sea. I think they're about 4 miles out to sea, but you can still hear the wind turbines spinning and spinning and spinning. Emily, why do you think putting them out to sea would be a good idea? Why do you think wind turbines are good when put out at sea?
Because they still make electricity, but they don't need to use coal.
Yeah, but why are they best used out at sea? And why do you think?
Because at the night or the afternoon, the sea will get many wind, and if this wind energy are in the sea, so it can get many electricity at night.
Yeah, good job. Well done, buddy. So yeah, that's a good reason. We put them out to sea because it's windier out at sea than it can be in the land. Right? What's a limitation of using wind energy?
Some place doesn't have wind.
Yeah, exactly. Not very windy sometimes. If there's no wind, is the wind turbine going to blow?
No.
Exactly, right. So it's a limitation of it. Good job. We have hydropower, hydroelectric. It comes from moving water. We use a flowing river, or we use waves that are happening all the time. Waves always happen. We can't stop them because it's made by the moon. Can we stop the moon from moving? No, we can't. We get waves constantly, and water always flows due to gravity. We use this. We use this energy from the flowing water to create hydroelectric energy. Very similar to wind turbines, right? We said a wind turbine spins. It spins a turbine and it has a magnet. We do the exact same with hydroelectric power. Water passes through and it makes a turbine spin. From that spinning magnet, again, we get electricity. Pizza, what do you think a limitation of hydroelectric power is?
They are very big and very expensive to build a dam.
Yeah.
Because they can high risk of dam breaching, and they cause damage to the environment around it by flooding the reservoir.
Oh, reservoir, yeah. It's a really good answer. Well done. Building dams is very expensive, right? Building giant hydroelectric powers, it's pretty expensive. It's difficult to just say, oh, let's just put this here. What we tend to have to do is we have to make one. We make a man-made lake. The water then passes through the hydroelectric dam. Yeah, good job, Pizza. So there's a couple here that you probably have not have heard of before, right? Geothermal. Geothermal energy is relating to heat from the Earth's surface. Middle of the Earth is hot, it's molten rock, it's all lava, right? That heat can then be used to create electricity. What happens is geothermal power plants take heat from underneath the Earth's surface, make usable energy. What they do is they pour water into the ground where there's a hot pocket in the earth. Water then comes back up as steam, and they use steam to power a turbine, like we saw with the wind power, like we saw with hydroelectricity. It follows the same method, right? But this time it's just using heat from the earth. Another one which we looked at is biomass energy. It's natural material, right? Energy can be attained by burning waste from animals, so from wood chips. So again, it's used to create biofuels. It can be unused parts of plants. Anything that's waste that could be used to be turned into energy, we call it biofuel, right? Again, it's a very natural, very non-polluted source of energy. It's very, very good for the earth. And we can keep renewing and renewing and renewing it. So quite a very, it's a very useful way of getting energy. It doesn't give you the most amount of energy like you will get from crude oil or from natural gas. It doesn't burn as high as a temperature. But again, it's still a renewable source of energy. So there's some new ones. So geothermal is heat from the ground, and biomass is natural products, natural material. Okay. So, what do you think? Let's take geothermal. Okay. What do you think? What's a positive of using geothermal energy? Energy from the earth. What do you think, James? What's a positive of using it? What do you think a positive point for using geothermal energy is?
The bad thing or the good thing?
Good thing, please. Let's talk about good things first.
It's
Well, is it renewable or non-renewable? The heat from the earth, do you think that will ever stop?
renewable.
Yeah, it's renewable, right? It's a renewable resource. You can't ever stop heat from the earth. What do you think a negative part is, Emily? What do you think a negative part of using geothermal energy is? You think it's cheap?
It's free.
I wouldn't say it's free. You think it's cheap? You think it's easy to do?
It's easy to find.
Well, if it's in the earth, maybe, yeah. You need to find places where the earth's crust is not that deep. That's pretty okay. Monkey, what do you think? What's a limitation, do you think? Yes, pizza. I think it's cheap.
It is like we have to dig it up, and maybe it could cause harm for the environment.
There we go. Right. To find places where we can like take geothermal energy, we probably have to drill down. We probably have to make space to do it, right? So it can be harmful for the environment. But let's look at biomass energy. What do you think a positive of bioenergy is? Comes from dead plants and bits of wood. What do you think a positive part is?
Can grow again.
Grow again, right? If we're using dead plants and animals, then we can grow the plants and animals again. Cool. And Nerva, what do you think a negative part of biofuel is?
Burning can cause smoke and make air pollution.
Yeah, maybe. Yeah. I agree with you, right? So the point of what I'm trying to get at is that anything we use, right, is going to be positive or negative. They're the main forms of renewable energy that we're going to look at for the rest of this lesson. So that's just an introduction for you. We're going to learn more about it, and your homework's going to have some about it as well. Laura, where did you go? Laura, help me with this question, please. Look at question number 1. Look carefully at this house. Even though it's not close to any town, it still has electricity. When you look at most houses, you see wires connected to them. Wires bring electricity to the house, to the refrigerator, lights, TV, etc. Some houses have underground wires, while others get their electricity from other sources. So, look at this house. Got lots of electricity, plenty of electricity day and night. How do you think it gets most of its electricity?
Solar panel?
Solar panels, right? Okay. Why do you think that? Why do you think day and night? Does the sun shine at night?
No, but it saves the energy.
Yeah, right. So here you can literally say is like, well, it's got plenty of electricity day and night. How does it get most of its electricity? Do you see any wires going to the house?
Well, no.
No, I don't. Okay. So you can say it's like, exactly. So you can look at the picture and you can say it's like, well, looking at the picture, I can see that it has really, really big solar panels, right? Those solar panels are huge. Covers pretty much the whole roof. You can say it's getting lots of electricity because it's got really big solar panels on the roof to absorb as much sunlight as possible. And during the day, it is storing the electricity for the night, right? Storing the electricity for the night. Monkey, do you think that's a...
And the night?
Yeah, day and the night. Monkey, do you think that's the best way for this house to get electricity? What do you think?
Maybe it is, or maybe not, because No, I don't think so because when the sun is, you don't have the sun like you have the sun much in winter, and then the house will not get as much electricity as in winter.
Okay. Let me ask you a question, Monkey, just as an interesting one. Right? It's a trick question. Where are you most likely to get sunburn?
Near the sun.
Yeah, obviously near the sun. Okay, but on the Earth, right? If you were to say, where are you most likely to get sunburn? Where in the Earth? Where would you be?
In the equator.
Yes, in the equator. Right. Okay. Right. Fine. It's a trick question, right? People who go skiing always get sunburn, right? You think, oh, it's cold. Yeah, it's cold. There's snow everywhere. You're also up a mountain, right? You're high up a mountain. You're still close to the sun. You get sunburn all the time. Skiers always get sunburn. You're more likely to get sunburn on the top of a mountain than you are at the beach. And that's just because you're closer to the sun. So when you think about that idea, Monkey, that even in winter, the sun is still there. You still get solar energy from the sun, even if it's cold. You can, right? The sun isn't out for as long, but it's still there. So this is how I want you to think going forwards. Okay. So for your homework for the night, I want you to go to your dimensions book, page 550, and I want you to do question 2 and 3. Okay. Not too long. It's just about everything that we've read there. Okay. We spoke about wind, solar, hydroelectric. So I want you to go through this. Have a look at everything we just went through there. Have a think about the different types of energy, the renewable energy we spoke about today. Fill in the answers here, and then fill in this question. Simple. What's the difference between a renewable and a non-renewable resource? You've done this loads. So question 2 and 3 for tomorrow. Thank you. Yes, Pizza, your question? Pizza, the question.
I did all of the that question in the dimension book, but I put it at school. Is it okay?
Yeah, I believe you.
I forgot.
Okay, but tomorrow I will ask you the answers.
Yeah.
Tomorrow I will ask you the answers to these questions anyway. Cool?
Okay.
Right, cool. Okay, everyone.
You can email my mom.
Bye-bye.
She will not.
Okay, right. Bye-bye, everybody.
Bye-bye.
Bye. Have a good day. Bye-bye.
Bye-bye.